this already week 6, week 5, right? And worst thing, you guys have an exam next week. Good thing, spring break is coming. I think the scope of the exam will be in our computer lab. I think it's from week 1 to week 3. Okay? So maybe you guys should recap what we did. Everything is on on our website. Okay? Today I'm gonna do something different from the previous one. So we have learned the regression, but today I wanna generate the random sample from normal distribution. Okay? We have studied about the normal distribution last week, and now we want to generate some samples from specific normal distribution. Okay? So we are working on the generating random sample, and especially today, I really want you to follow my code, because maybe at the end of our course, class, I want to get some values from your code. Okay? So just please help me. Please follow my code. And now I want to start with this code. So I want to declare my data set name as my underbar data, and then in that data I want to put two values. One is I, and then the second variable name is y. Okay? So we have I and y. Maybe let's say I want to generate the random sample from standard normal distribution. So among the code that I wrote here, this part ran parentheses, and then we have 3 parameters of that rand function. Maybe some of you you can already guess that rand function generates a random sample from specific distribution. Okay? And inside of the parentheses, you can specify which distribution you want to use. So this part, hey, I want to generate a random sample from normal distribution whose mean is 0 and standard deviation is 1. Okay? So when we have a normal distribution, if we know about the mean and standard deviation, we can actually specify that distribution, right, using that information. And this from do to n, these 4 lines, what that code means is that we ask SAS do something repeatedly, like 1,000 times in this context. Okay? So I declare a variable I as an index variable. Okay? So we ask do SAS something from I is equal to 1,000. We ask it to do these 2 lines. Okay? And then the first line, hey, says generate the random sample from the standard normal distribution, and once you generate it, I want you to assign that value to y. Okay? And then just make them as an output. And then when the SAS reads up to here, it does, and then the next line is end, but it doesn't end because index value is not 1,000 yet. Okay, so for I is equal to 1, it will generate the 1 sample from the standard normal distribution, and then just go back to the do code line again. It just switched the from 1 to 2 for the value of the I. Okay? And then after that, it will repeat the same thing. So it will repeat these 2 lines like 1,000 times from I is equal to 1 to 1,000. Okay? So if you imagine our result of our data set, like my data, it will show you the two lines. One is for I, one line is for Y. And for each I, we have value of Y. And then that collection of the Y values follows the standard normal distribution. Okay? Does it make sense? Okay. So let's just run it. You run that. Nothing will happen maybe, but we can check our result using print data is equal to my data. And if you run it, you can see 1,000 values of I and Y. And then you can check the last value of I is 1,000, so that means we have 1,000 observations from standard normal distribution. Okay. Now, so when we see the data, our original goal is to generate a random sample. So maybe since the first observation column is provided by the SAS system, so we cannot remove that. That's just a basic option. But I can get rid of the I column because I don't care, right? So to preserve only Y value, you can put parentheses after your data name. Say SAS keep only Y. Yep.
Mine's not showing them.
So I put on the bar, and then we should just go up. Oh, so here is the data, and then my on the bar. It should be same, right? So you declare this SYMMA. Get rid of this part. So this is our data set name. And then in here, we want to print out this data set. So run it and then yep. So when you look at the Y value, your Y value, it will be different than mine because you are generating random sample. I am generating random sample. So it should be different. But when you look at the distribution of them, I mean your data and my data, it should be really similar to standard normal distribution, right? How can you check? How can you check that your generated sample follows the standard normal distribution? Is there any SAS code you can use among the code you have learned so far? Yep. Univariate. Yep. So if you use the univariate, what you can do? You can draw the plot, right? So let's just use the univariate, and then to see that the histogram of the maybe our data set looks like standard normal. So how can I do that? Using plot univariate, and then maybe plot data is equal to my data, and then we have variable name and Y and then 1. Okay. And if you run it, we have this one. And we have this nice histogram. Looks like symmetrical, right? Is there any measure that you can be assured this follows the standard normal? I mean, now based on the histogram, maybe we can guess that this is symmetrical at least, right? And then what's the next thing you can check? I mean, you have a lot of results from the univariate, and what is the criteria or what is the measure you can use for checking this distribution is actually the standard normal. Yep. Mean and standard deviation, right? So what is the mean and standard deviation here? We have here, we have mean as negative 0.01. And then maybe yours also different, but like really closer to 0, right? Right? And then standard deviation should be really closer to 1. Okay? Because we draw the random sample from the standard normal distribution. If that random sample actually follows the standard normal distribution, then sample mean and sample standard deviation should be really close to the population mean and standard deviation. And also, maybe I can say, this is the symmetrical because like the median is like 0.008 and mean is also 0.014, which is like closer to each other. So close to each other. So maybe we can say, it's symmetrical. We have symmetrical distribution here. Now I want to change some parameter into. Now instead of generating the 1,000 observation, I want a specific number here. I want to generate the 33,343. I'm not sure. Number of students. 33334. Okay. That's the number of registered students in 2016 in New Bible. Okay. And then I want to change this number into maybe 64. And maybe standard deviation is around maybe 4. 4. Okay. So I'm just trying to generate the theoretical population data. So after run this code, I would get 33,334 observations. And maybe we can think the observation is like the heights of the students. Okay, does it make sense? So let's just do it. Let's just run the code, and then now I want to check the data that I generate. But if I just run that print, it will show the whole data set. But I don't want to check all of them. So maybe I can just put observation like 30. And then run. Then I'll get first 30 data points in my like whole data set. 33,000, about 33,000 data set. I only get first 30 data points. Okay, and it looks like it follows that normal distribution whose mean is like 64 and that standard deviation 3, right? And you can also check. I mean, instead of using univariate, if you're using the prop univariate, it will gives you a lot of results. So maybe there are more compact procedure. Prop means and then data is like my data, and variable I have there is y1. Then it will give you just a mean, standard deviation, minimum, and maximum. Okay. So if you calculate that, I have 16.4 as my mean, and standard deviation is 3.9. Okay. Yeah, 3.9 because I set the parameter standard deviation, population standard deviation it was 4. So looks like it follows that normal distribution. Okay. And then just one last thing. I want to put this one. Let's see. And then I want you guys use the same seed. Maybe I want to do just 32000. And then just run it. Okay. This seed, maybe you can think like when we use the same seed, it will generate the same random sample. So your number and my number will be the same. Okay, but I mean, that's what happens in other language, but I actually checked the fact in SAS, but it doesn't work really well. But let's just use the same seed. Okay? So I want you guys to use the seed number 32,000, and then to generate the sample from normal distribution 64.4, and then after generate that, just drop C. Okay? So just run the whole thing. Run this. Okay. Yep.
I'm just curious, what is the point of the drop seed?
Drop seed means we declare the seed first, right? And then generating the random sample using that seed, right? But if you don't drop the seed, maybe next time when you want to generate a random sample, maybe it will use the same seed, but you don't want to get that situation, right? So just recap what I did here. We just generating the population data set, right? We're just generating the imaginary about 33,000 students, and then we get the information about their height. Okay, and here is the situation that I want you to think about. Now, you wanna know about the population mean, which means like if you can ask every single student in our University of Iowa, you can get their information and then take the sample mean. That's the true value, the average of the height in all students in U of Iowa, right? That's the goal. You want to figure out what is that number, okay? But in our real life, if you want to figure out that number, you cannot ask all of them, right? what you can do, you can just go to the street and then just grab a random person and then ask their height, right? So maybe you can just write it down their height. So it is impossible to ask every single student. So let's say you want to ask 30 of them. Okay? So now, using this code, using this code, I can grab a random sample from existing data set. Okay? So this survey select procedure needs existing data. So we already generated my underbar data, right? It has information about the student's height, and then using this one, I can grab the random size of the sample from that data set. Okay? So what does this mean? It means I want to use the survey select procedure, and that procedure I assign 4 options. Okay? First one, hey, I want to select a random sample from the existing data, and that existing data is my underbar data. Okay? We have a lot of information here, but I want to grab only 100 people. Okay? And then if I grab that, I want to assign these value and then make another data names like data set names like sample underbar data. Okay? So if you run this one, we're gonna get another data set which has only 100 data points from this my data. Okay? And then method is there are a lot of methods that you can draw the sample from the existing data. One thing you can do, just randomly select. Simply randomly select of the samples, right? So simple random select. Okay? So I want SAS using the simple random selection method, make a sample size of 100 data points, and I want to name that data as sample underbar data. Okay? So let's run that. If I run that, I can check clock print data is equal to sample data. Then I will get 100 people's height. Okay, so everyone can get this result, right? You can get your own 100 people, right? Anybody who has a problem get this one? Right? You should make sure you can get your own data set because I'm about to ask your value to collect the data. Alright, so you guys, all of you have your own sample underbar data, right? So what I want you to do, just calculate the sample mean of your own 100 people. Okay? So proc, not univariate means, and then data is sample data, and then variable name is y, and run. If I run this, I got 6.4.4, and then my sample standard deviation is 3.700. Okay. What is your number? Yup, sample is 63.772. What is your number? 64.52. Do you have?
I'm
No?
still going.
Okay. You have number?
64.04.
64.04. Can I get your number?
64.01.
64.01.
64.17.
17?
Yeah.
And do you have number?
64.63.
60?
Yes. 64.74.
64.74? Okay. Okay, I want you to do the same thing. Now, I want you to change that number into previously 100, right? Maybe let's just do 10,000. And then, so run that. Don't print it because it has a lot of numbers. So I don't want you to run this one. You can just calculate the sample mean again. Okay, I got 64.01. Anybody can get the number. Do you have number?
64.03.
64.03. Do you have number? 64.12. 60.01. Anybody? Jennifer, do you have number?
It's still going.
You have number?
Yeah, 64.02.
64.02.
64.03.
64.03. 64.02. I need one more.
63.98.
63.98. Alright. Okay. What I'm gonna do, it was previously 100. And then this is like 10,000.
You don't have to do that.
No. You don't need to do this. But, so run. So we have made these two columns, right? The first column, I mean, both column has 8 numbers, but each numbers in the first column, that number made by information of 100 people, right? We just draw the 100 people, or maybe, in other words, we go to the street and then ask the random person type for 100 people. We met 100 people, ask them, and then take the sample average, sample mean, right? So each number has 100 people's information, right? And then we imagine we did the 8 times repeatedly, and then this value, that number is actually it's not the same number. It has a huge information than the first column, right? It has 10,000 people's information, and then you combine them, take the average, and then just total, right? So each number generated by information of the 10,000 people's heights information. Right? What is the difference between these two columns? Yep.
Like the second one was a lot closer to the population mean.
You know, we already know the population mean and standard deviation, which is 64. But even if we don't know that population, one thing for sure is if this one follows that the population distribution, that the sample mean. I mean, each line, what we did is we estimate the population mean. And then the one thing you can sure, when your sample size is larger and larger, your estimate and the variation of your estimate will be really small. Okay? When you think about the numbers in here, it will just distribute it around the 64, and it doesn't change, right? Every time you just ask 10,000 people and then take the sample average, it will really closer to 64. Okay? But however, if your sample size is a little less than this one, your estimate varies more than before. Okay? It will, sometimes you get 63, and then sometimes you get 64.7, right? Okay? Does it make sense? So once you have a larger sample size, your estimate, the variation of your estimate will be closer and closer. Okay? And then later time, you actually can calculate how much it will decrease. Okay? It will be sample standard deviation divided by square root of n. Okay? And then you're going to use that fact to calculate some probability in a later course of this course. Okay? To make you understand what's going on here, I am just writing just one simple program in Excel. So this one is really simple. I want to generate the one number between 0 and 1. Okay? So that's why I got horizontal line from 0 and 1. Okay? So, and if I hit this button, I will get one number, and this time it will just close to maybe 0.5. If I hit it again and again, every time I hit this one, I will get just random number from 0 to 1. Okay? Now, when you think about the probability of getting one number, I mean each number has a equal probability to get picked up, then your population mean will be 0.5. Okay? Okay? So, I mean, from 0 to 1, and then if we have an equal probability for picking one number, then the middle point will be 0.5, right? So that's, let's say this one, I want to estimate the dislocation. That's a parameter. That's our parameter. Purple vertical bar, vertical line indicates the population mean. And then now, if I change this one into 3, if I hit this one, I got 3 samples from 0 to 1. Where I got here, I got here, and I got here. Okay? And then what does the vertical green bar means? The green bar means sample mean of that 3 numbers. Okay? If I take the average of this red dot, 1, 2, 3, that sample mean is this one. Okay? So if I hit it again, I'm gonna get other 3 random sample, and my sample mean of these 3 red dots is green bar. Okay? So what you can see is if I use that green bar to estimate my parameter, which is location of the purple bar, this is my error of my estimate, right? Does it make sense? Okay. So it looks just that green bar moving around anywhere between 0 and 1, right? But what if I change this number into 100? That means I want to pick 100 numbers from between 0 and 1, and then I'm gonna take the average of that to estimate my location of the purple one. So if I pick that one, I got 100 numbers here, and then my green bar is here. Okay. Now if I hit it again, what is the difference between the case where we have like sample size is 3, and then now we have like changed the sample size into 100? What is the difference between these 2 situations?
So it's closer to the mean.
Can you say
If you have more data points, it stays closer to the mean of that, like the whole.
when you have a more sample, then statistical.
When you have the 100 data points, it stays closer to the 0.5.
Which one? Like green bar, right?
Yeah.
Green bar stay closer to the purple bar. When we have like, when we think about the n is 3, it will just moving around, right? But this time, that the green bar kind of like moving really closer to the purple one, right? What if I had 10,000? Then can you guys see like my green bar is just around here, and then it just stay there, right? Now green bar is just actually almost same as the purple one, right? This one, when you think about the variation of the green bar, that's connected to these 2 columns, right? When we have like small size sample, the variation is larger than when we have larger sample size. Does it make sense? Okay. So we are using this property to estimate the population mean in the later chapter. So you guys have learned about what is the standardization formula, and then if you standardize one value to the standard normal case, you can calculate the probability using the standard normal table, right? And later part, when you have a specific sample size, you can figure out that sample mean follows some specific normal distribution, and you have to calculate that standard deviation of that distribution using a sample size of n. So just maybe the key point of this whole computer lab is when you have a larger sample, your green bar, like distribution of the sample mean, will be different than the population mean. Does it make sense? It will be more, it will have a same mean, but like different standard deviation. Okay? Does it make sense? Even if you don't understand this one, maybe we'll come back to like same thing using specific problem. Okay, I'm done today. You guys can go.